Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is search in rotated sorted array. Okay, so you're given an array which is sorted in non-decreasing order and not necessary with distinct value. So there might be a duplicate value in this. So before going past to your function, num's array is rotated at unknown pivot index. Index k. Okay, so you have given an array and it is in a sorted order and it's you can say rotate at some index. Okay, so what you have to do, given the array after rotation and an integer target, you have to find out whether the target is present in that array or not. Okay, so let's see with an example. Okay, so let's take this example. So we have given this array and this is a sorted array. Like if you can see from this point, this is like 0 0 1 and 2. After that it is rotated like after this, so the new elements are at here, so 2 5 and 6. So this is in a sorted and in ascending order, but this is rotated. Okay, so if you have to search any element in this, so you can apply a linear search and you can directly get the element, and it's you can say a order of n of approach. But can we optimize it? Okay, so if you go with the normal linear search, you can simply solve it. But if you can see, the question is searching in array. So with searching, we can use something called a binary search. Okay, so let's see how we can use a binary search over here. Is if you can see this array, like it's let me write it down like this. This is 2 5 6 0 0 1 2. If you can see, first we increase like 2 5 6, then after that there is a decrease at this point. Okay, then like there are same elements, so this is a duplicate, so we come at here and then we again increase. Okay, so you can see like we have this sorted array and after this we have this sorted array. Okay, and these two are duplicate. Okay, let's skip this duplicate, first understand this only in the increasing manner. Okay, so let's say if the element is 5, we have to search. Okay, so what we will do, we will take a start from here and we will take our end from here and we will calculate the mid. Okay, so let's take a middle. It will be, one second, let me give the indexes, 0 1 2 3 4 5 6. So 6 plus 0 divided by 2, so this is the middle. Okay, this is the middle. So what we can see, this is a 0 once. So we have calculated our mid and now we will check with our start. Okay, so if we see like if our array of start is, we can say, is less than equal to array of mid, then will lies in this condition. Okay, will lie in this condition, but else if it is not, then that means this will be in the second part. Okay, so this will be in the second part. So as you can see, this 2 is less than 0 and we will, so now this will be in the, so we will go in the second part. Okay, but before going to the second part, we need to find whether this element target is in this range or not. Okay, so how can we check? We can check whether the element, like the target, is lies from mid to this range. If it is lies to this range, then update your start and take your start at here. Okay, if it is not, you have to come in this range. Okay, as you can see, from 0 array of mid to this 2, this 5 not lies in this range, so we will update our end will now come at here. Okay, let's again calculate the middle. So we will calculate the mid, so this will be mid, and first condition is in binary search, we just compare the mid with the target and you can see this is equal to our target, so we just return true. Okay, let's take one more example. Okay, so let's take this example and target as 5. Okay, so let's give the indexes. So this is 0 1 2 3 4 5 6 7 8. Okay, so as you can see, this is like increasing and then suddenly it decrease and after that it increase. Okay, so let's do it from here. Okay, so what we will do, we will calculate the mid again. So this is our start, this is our end. We will calculate the mid. So this time this will be our mid. Okay, this is our mid. So we lies in this range. This is start, this is mid, and now we will check whether this target is lies in this range or not. Like before checking, like we need to check whether we need to go for this range, like this part or this part. Okay, first step is to compare with mid. If it is not equal to, then we have to go either to this part or to this part. So we will check whether this is lies in this range. So as you can see, array of start is less than equal to array of mid, so we lies in this range. Like 4 is less than equal to 8, so that means we need to go in this direction. And what you have to do, you have to update your end. But before updating your end, you have to make sure that target should lies in this range. If not, then you have to update your start. Okay, so we will check whether this target is lies in this range. So as you can see, from array of start to array of mid, 5 is less lies in this range, so we will update our end. So end will come now here. Okay, now we again calculate the mid. So 0 plus 3 divided by 2, which is 1, so this is our mid. And we check with mid equal to target, so we just return true. Okay, so let's like this example is for, you can say, this is the second part of the same question. So this is search in rotated sorted array 2. So what's the difference between first and second? So in second, the element may be duplicate. Okay, let's take this example again. Okay, so what's the difference between second part and the first part? So in second, we have duplicate elements, so we need to update our, like only one condition we need to update. So what we will do, this is again our start, this is again our end, and this is indexing 0 1 2 3 4 5 6. We will again calculate the mid. So mid is this. So like at this condition, it just lies in this, you can say we got our target. But let's say our mid is lie at here. Okay, let's say. So first we need to check whether this is in the same, like this is in same increasing manner or not, or otherwise it will be in the other, you can say, in this manner. Okay, so what we will check, if array of start is array of greater than mids, yes, it equal to this. So this is our condition. If array of start is less than equal to array of mid, that means we lies in this range only. If it is lies in this, we need to check for target, and you can see target is not lies in the range, so we will update our start. So we have to solve for this part. Okay, so our start is now at here. Now we again calculate the mid. So 3 plus 6 is 9, and 9 divided by 2 is 4. Okay, so what we have to do is basically we have to do the same approach with our previous you can say previous sorted array part 1. The condition will be added is like if your start is equal to mid and your mid is also equal to end. So what you have to do, you just have to increment your start and end. Okay, so let's take one more example that will be clear to you. So this is 1 0 1 1 1. Okay, and we have to search our target of 0. Okay, target is 0, so we will calculate the same. This is start, this is end. Okay, so 0 1 2 3 4. Let's calculate the mid. So mid is this. Okay, now our first condition to check whether it is lies in this condition, like in the first increasing interval or the second increasing interval. How can we check? We can check in the range. Okay, like if array start is less than equal to mid, that means it's lies in this. But if array of mid is less than, then it means it's lies in this condition. But if you compare like array of start with less than equal to array of mid, you can say yes. But so you will check like if array of start is less than equal to array of mid, yes, it lies in this first interval. So we have encountered like this, we have to solve. Okay, but what we after this we check whether this lies in this range, the target is lies in this range or not. How are we checking? We are checking with start element and we are checking with middle element. So what we are doing is basically we check if array of start is, you can say, less than equal to target, and array of end or mid is less than equal to target, then you have to update your end. Okay, otherwise you have to update your left, like this is not in this your start mid plus one, but you can see like it say like this is one, this condition is not true, and it's saying like you have to update your, because array of start is 1 and your target is 0, but condition is like array of start should be less than, but what you are doing is you will update your start, so you will make your start 2 at this point. Okay, so we have to handle this condition only. What we have to do is we have to check whether this array of start is equal to array of mid. If it is equal to, so what you have to do, you have to update your start also, and this now start will come at here, and again you have to check with array of end also is equal to mid, so you have to update your end also, like increment s and decrement end. Now you will again solve this problem, so you will again calculate your mid, so mid lies in this, but now this condition is true. If array start is less than equal to mid, yes, this is in this range 0 and 1, and you will check whether this array of start is less than equal to target. Yes, it is. 0 is less than equal to target, and it is lies in only this range, so we'll update our end and now come at here and we'll calculate the mid, and this is the only target. Okay, it will be more clear if we write the code for this. Okay, so let's take the variable, so let's take n num start length, we'll take left, and let's give it a left equal to 0 and right equal to n minus 1. So while your left, you have to apply binary search, left is less than equal to right. First step is to calculate the mid. Okay, left plus right minus left divided by 2. If your nums of middle is equal to target, you have to return the mid. Okay, then else if your nums of start, let's give a left variable, left is less than equal to nums of mid, that means it is in this first increasing interval. So what you have to do, you have to update your end by checking the range of the target. Okay, so what we will do, so this is in the first interval, then you have to check whether your target is in the first interval. So if nums of left is less than equal to target and target is less than equal to nums of mid, if it is true, then you have to update your right equal to mid minus 1, else you have to update your left, there it is, this is not present in this range. Okay, else what you have to do, you have to basically do if nums of mid is less than equal to target and target is less than equal to nums of right, then you have to update your start equal to mid plus 1, sorry, it's a left pointer, and else you have to update your right mid minus 1. Okay, and if actually we have to return the boolean, so we have to return true here. If nothing condition match, we just return the false. Okay, this code works if this question is for search in a rotated sorted array part 1, but there are duplicate element also, so we need to add one more condition. Okay, so what is that condition? Else if nums of, you can say, left is, let me, equal to nums of mid and nums of mid is equal to nums of left, oh sorry, right, then you do increment your left pointer and decrement your right pointer. So this is the extra condition that we need to add for the duplicate, otherwise it's the same for the first part of the question. Let's run it. Let's see. So this is accepted, let's submit it. Hope it will run. So our code is submitted. The time complexity for this is like on an average it's a binary search only, so it's a order of log n, but If it always lies in this condition, so it's a worst case, you can say, then it's our order of n. Hope you like it. Thank you for watching my video, and do join the Telegram group if you have any doubt and any concern. Thank you.